We've seen how to add two vectors together, but what happens if you want to add more than two vectors together? Here we have three vectors, vector A, vector B and vector C, and we want to add the two together. So we want to know what is the result when we add A plus B plus C. It's the same method that we've used before. We go head to tail, so we want vector A, so we've got to get the head of vector A and add the tail of vector B. And so what we do is we'll get B, and now in your case you'll have to draw the diagram separately, so you line up the head of A with the tail of B, and we've got that one. And then we will get vector C, and we'll do the same with it. So we want B plus C, so we've got the head of B joined to the tail of C. And that will allow us to work out what the resultant is. So we've got A plus B plus C, and the resultant will be as if you started at the very start of A and you finished at the very end of C, and we can just draw a vector straight across there, and I like to put two arrows on there to show that that is a resultant. We could call it another name, maybe vector D, so it's simply vector D. So A plus B plus C adds up to vector D. Okay, say we've got now a closed shape, and we want to add those four vectors together, and we want to know what vector in this situation down here, what vector A plus B plus C plus D is equal to. Now if you look at the diagram, we'll just break it into its two at a time. So we'll go A plus B. If we start here, we go all the way up there into there, we've effectively gone straight across to there, so we can call that vector C. We've already got a C, so let's make it vector E. So A plus B is vector E plus C plus D. Now we can add vector E plus C, so vector E plus C, and we'll get, when we add that to that, so we've finished down here, we're going to get a vector that's just going straight down to there. Now C, vector E plus C plus D, or vector E plus C, vector E plus C is actually equal to, it's got the same length as vector D but going in the opposite direction. So E plus C is minus vector D plus vector D, and that's like vector D minus vector D, and so that is 0. And 0 is what's sometimes called the null vector. And this applies to any closed shape. This was just a random one I chose, but it doesn't matter how many vectors go to make up a closed shape. As long as you are adding all the vectors in a closed shape where you start and finish at the same spot, you'll get the null vector. And it's by just logic. If you have not moved, if you've gone around and you've actually gone all this distance and you actually ended up back at the same spot where you started from, that results in a net displacement. So it must have a 0 null vector as a result of adding all those closed shapes together.